I want to see that. Let's record. All right, good. So in this example here, let's go ahead and read through the example and see what it's asking here. So we have a management training company prices a seminar based on, we're using a technique that $400 per person. Then they expect that 1,000 people will attend the seminar. So with this price per person, 1,000 people will attend the seminar. The company estimate that for each $5 reduction in price, if they lower the price per person by $5, an additional 20 people will attend the seminar. And that's, I don't know, we don't know where they're getting that information from. They're just estimating. So they're saying that if they reduce it by $5 per person, an additional 20 people will attend a seminar. Our goal is trying to figure out, okay, well, if that's the case, how much should the company charge per person for the seminar in order to maximize its revenue? So this deal with the revenue function, right? So we want to figure out what's the price per person to have the highest revenue as possible. For these type of problems, student will figure out a way to kind of like manually calculate this and figure out, what price per person will be, maximum revenue, things like that. So what you can do, just kind of like scratch work here, what we can do is, okay, well, we know that at 400, 1,000 people will attend. That's the base, that's the starting value there that we're looking at. So that's the 400,000 revenue, right? And then if we decrease the price by $5, so we're looking at $395, additional 20 people will attend the revenue, so we're looking at 10, 20. And so the student can do this on the side to see at what price we have a maximum revenue here. And that's fine too, but the whole point of this is not just sit there and crunch a bunch of numbers. The whole point of this is using calculus to do this, a little more advanced approach to figure out the critical value that maximize revenue, how do we construct revenue functions and things like that. But you can actually go through this and spend about 10 minutes in doing this and figure out, at what value of price we'll use the maximum revenue. You can do that. But again, I'm not teaching you guys to do this here. I mean, we learned something a little more above that, more conceptual than just crunching numbers here. So what we're going to do here is we're going to try to construct a revenue function. So for this problem here, the revenue, to calculate the revenue, will you say that it's going to be price per person, right, for this seminar, right? And then how many people attend the seminar, right? Well, how do we calculate the price? We want to figure out, how many times or what will be the new price. The old price is at 400. The new price can be each $5 reduction. And then the number of people attend the seminar is starting out at $1,000, 1,000 people, and it's going to increase by extra 20 people for each correspond $5 reduction in price. So what we can do here is we can start by letting the variable that is changing, and what is changing in this case is the price is changing by $5 reduction. So that's going to be our variable. So the variable here is going to be how many times, the number of times of the reduction price of $5. Okay, so that's going to be our price there. If X is 1, that means we reduce by $5. If X is 2, we reduce by $10. If X is 3, we reduce by $15. So the variable itself, X, is changing based on how many times we reduce the price. So if X is the number of $5 reduction in price, okay, how will we write an expression? How will we write an expression for price per person in this seminar here? Okay, what is the expression to denote the price per person for the seminar? We said just kind of follow from this X here. So if X is number of times that we reduce the $5 in price, what will be the new expression now to denote the price per person? So it starts with $400, right? And we want to include the new price. We want to use the new price by reduce how many $5, we don't know, but we want to write a general expression to denote that. So will you say the expression to denote the price per person now is not $400, but be $400 what? Minus?
Minus
Not
5x.
5x, because we don't know how many times we need to reduce this by 5, right? So it's gonna be 5x as many as we need to yield the maximum revenue. We don't know, but that's the expression that will describe the new price per person in terms of x, and x is the number of times we reduce the price by $5. Okay, so here's the thing. So now, what will be the expression that denote the demand, denote the number of people will attend the seminar based on x? So this expression will be in terms of x. Okay, so how would you calculate the new expression? How would you calculate the new demand of people attend the seminar based on the x reduction in price?
I'm guessing
Derivative.
Yeah, derivative.
Not derivatives. It's just let's start with 1,000 people. Okay, if we start 1,000 people, and if we
That's the interval.
Yeah. Yeah. So if we increase the price by $5, what's the real demand now?
1,000 plus 20x.
Very good, right? So for each reduction $5, the demand is increasing by 20 people. Yes. So if x is 1, then the price is $395, and then 1,020 people attend. If x is 2, then the price is $390, and then there will be 1,020 people attend, right? So those are the new expression that we're going to work with to construct a revenue function. Okay. So now we're ready to write that revenue function. So we're going to say revenue is going to be based on x. X is the number of price reduction in $5. So we said the price now is 400 minus 5x. And then how many people would be 1,000 plus 20x. Okay. And then x is just the number of $5 reduction in price. Okay. So we have a revenue functions. We want to maximize this. Just like we learned in the previous lesson, to maximize any function, we looking for the local extrema. To do that, we need the first derivative and set that equal to 0. So what we want to do here is kind of, well, you can do the product rule to find our prime of x, but what I'm going to do is I'm going to go ahead and FOIL this out and use just the power rule to make it easier. So we have 400,000 plus plus what here, plus we got 8,000, and then we have 5,000. Is that right? Negative 5,000. So 8,000. So is that 3,000 in the middle there? What do you say? And then minus 100 x squared. Did I do that math correctly for the mirror term there? Okay. All right, so let's move on here. So we can take the derivative now, and that's going to become 3,000 minus 200x. So now we're ready to set this equal to 0 to find the critical value. So that means 3,000 equal to 200x, and therefore x is 15. Okay. So what does this mean? This means, so anyway, we will still have to use the second derivative to show that this here will yield a maximum. But from what we see there, the revenue functions is already a upside down parabola. We know this will have a maximum. It's an open downward parabola. It's concave down. So we don't need to verify that. At this point here, will yield maximum. So this means if the company reduce the $5 15 times, the company will have a maximum revenue. Okay, so that's the goal here. We're trying to find is that how much should the company charge for the seminar in order to maximize revenue? What is the maximum revenue? So we answer this by saying that the company should charge 400 minus 5 times 15. Oh, what is that? 325 per person. And then with will yield per person. So let me rewrite this. Oops. Okay. So we say that $325 per person will yield max revenue of $422,500. And I'll let you guys figure out how I get that number there. Any questions so far, guys? So the hardest part for this example here, Michael, or in the rest of us here, is being able to construct that or write that revenue function based on the price reductions and the corresponding demand, and the corresponding demand or the number of people who will attend is for each for each $5 reduction, there's an additional 20 people will attend, so we have to incorporate that in terms of the variable. So as x changing, the demands also changed by 20. So the 400 minus 5x and 1,000 plus 20x. That's probably the most challenging part, is being able to set that up there. And then 5 and 6 here, these are similar example for you to try on your own. Okay, I'll let you guys work on that before we do more example. But before I stop recording this here, do you guys have any question on this here?
Nope.
No, everything's good.
Yeah, it's pretty self-explanatory. I mean, it's really nothing new.
I'm glad to hear that. The part that you would have to play around with this here once you get to similar example. Okay. So let me know, and then we'll on Thursday.
Yeah, that might be like one of the more difficult parts.
But now you have this example to refer to, Cody, is that other problem will follow this type format. You have the price reduction, increase, decreasing versus the demand is decreasing and increasing. This example here is deal with the number of the average nuts used per tree versus you have a plant acre that where you plant a tree, and then if you plant additional tree, then you expect to less number of nuts used per tree just because you have less nutrition, things like that. So that's a really good example. And this one here deal with car rental prices per day, and if you increase the number of if you increase the prices for renting a car, then you expect to less people will rent the car. So these are really good example. I want you guys playing around this, and we'll come back on Thursday, or let's attempt the homework. We'll regroup on Thursday and see what kind of question you may have. But I'm gonna go ahead and upload this video on YouTube though. Okay, so that way you can watch it again later if you want to. Okay. I think my face show in here for a little bit, and then your face as well. If you don't feel comfortable, we don't have to upload this.